Hello everyone and welcome back to Simplilearn. Today we are going to learn about one of the most important technologies used in modern AI powered applications, that is Pinecone database. In this hands-on tutorial, we will understand how semantic search works, what vectors actually are, and why traditional databases are not enough for intelligent search system. And finally, we are going to do hands-on tutorial using FastAPI. So guys, if you want to learn more about it, then watch this video till the end. Now, before we move ahead, here's the agenda of our today's tutorial. First of all, we are going to understand the difference between a traditional search and semantic search. Then we are going to learn about what vectors are and what are embeddings. After that, we are going to understand how vector databases work. Then we will explore Pinecone and understand why Pinecone is used in AI applications. And finally, we are going to build a FastAPI application connected with Pinecone. Now, here is a short quiz to test your knowledge. Which of the following statement best describes a vector database like Pinecone? And your options are: it stores only SQL tables, it searches using exact keyword matching only, or it stores vectors and find results based on meaning and similarity, or it is used only for image storage. Please mention your answers in the comment section below. Now, before we start the session, just a quick info guys, Simplilearn has got professional certificate program in agentic AI and multi-agent systems. In this, you are going to get agentic AI certificate, where you are going to learn from AI models to autonomous multi-agent systems. You are also going to learn how to design autonomous AI systems and lead AI-driven innovation. Also, you're going to strengthen your skills through 40+ demos and 10+ guided practice. And finally, you are going to gain hands-on experience with 7 projects. And also, the industry partner for this certification course is Microsoft. So guys, hurry up now and join the course. The course link is mentioned in the description box. So let's get started. So guys, let us first try to understand what exactly is Pinecone. So Pinecone is not a traditional database like MySQL or MongoDB. Now, what exactly is a traditional database? When you talk about the use case scenario, a traditional database is great when we want to search exact values, such as, let's say you are searching for username, ID, or let's say the order number or the product name. And when you search it, you get the exact result. But many real-world applications do not work with exact words only. Sometimes users search with different words, but they still expect the correct result. For example, let's say someone searches, I want to become a data analyst, but the course title in the database is Business Analytics with Power BI and SQL. So in a normal keyword search, the result may not appear because the exact words are different. But in semantic search, the system understands the meaning behind the search. It understands that become a data analyst is related to analytics like Power BI, SQL, codes and reporting. And this is where databases like Pinecone shines and becomes very useful. So in a nutshell, if I have to say, Pinecone is a vector database. It stores data in the form of vectors and helps us find similar items based on meaning, not just exact keyword matching. Now let's understand what vectors are in very simple way. So guys, a vector is just a list of numbers that represents the meaning of something. For example, let's take a sentence. For example, I write all over here, say I want to learn Python, okay, for let's say data science. Now, we all know that a machine cannot understand this sentence like humans do. So we convert this sentence into numbers using an embedding model. Now, this model, what it does is, it is going to convert this all into numbers. And the output may something look like. For example, let's say it could be, for example, it could be 0.12, 0.45, let's say 0.89, let's say 0.76, let's say 0.33, 0.67, and let's say 0.10 for all the words that I have written here. So each number all over here captures some hidden meaning about sentence. One number may represent the topic, one number may represent the intent, another may represent the similarity with data science, and so on and so forth. And we do not manually decide these meanings. The embedding model learns them automatically and it gives the output something like this. Now imagine another sentence. For example, if I write, all over here. Best course, let's say all over here to start, for example, a career in data science, or let's say career in data analytics. Now guys, this sentence may also be converted into similar vectors because the meaning is close to the first sentence. So when a user searches for something, we convert the user search query into a vector and ask Pinecone for the related results. For example, let's say if I say, find me the stored vectors that are closest to this query vector that I have given all over here. And its vector would be created something like this. And what basically we are doing all over here is similarity search. So a real software application of this is a course recommendation or a semantic search system. Let's say we are building a course search feature for an edtech platform. We store course descriptions in the Pinecone as vectors. Now, when a learner searches that, let's say I want to get a job in cloud computing, Pinecone can return courses like AWS Solutions Architect, Azure Fundamentals, Cloud Computing Bootcamp, DevOps with AWS. So even if the exact phrase job in cloud computing is not present in the course title, all those things, but Pinecone can still find relevant results because it searches based on meaning. And this same idea can be used in many real applications, such as customer support search, where users ask questions in natural language and get right help in the article. Or let's take up example of an e-commerce search where a user searches, let's say for example, he's looking for a comfortable shoes for running and he gets the relevant sport shoes. Also, you can find the application and resume matching where a recruiter searches for Python developer with machine learning experience and get the similar candidate profile. Now, another example could be document search, where let's say employee is searching for company policies, report, or training material, and he gets the required result. Now that we have understood what vectors are and what exactly is semantic search, let us try to build a simple FastAPI application that connects with Pinecone and exposes vector database operations through APIs. Now, I'll be using VS Code for the same. But before that, guys, you need to set up your account on Pinecone. And it's a very simple and easy process. First, go to official website of Pinecone. So just click on this link and click on Start Building. Now, when you click on Start Building, it is going to ask you to log in. And it is going to show you various means such that you can log in. So currently I have logged in, so it's not showing, but you will get, let's say, Google authentication, GitHub, LinkedIn, and all those things. So you can do the OAuth and you will be directed all over here. Now you'll also get an API key when you first log in. Now, if you go all over here, get started, okay? So you can see this API key will be prompted all over here, or you can create your API keys. So you can see the default API key is created, or you can just click on plus and give your API key name and you can create the API key. Now also it is using AWS Cloud and it is on the East region of the US. So that's what the configuration is there. Now what you need to do all over here, let's create the main folder. Let's say this is a Python demo and there are three important files that you need to have: main.py, .env, and Pinecone. Now first let us talk about .env file. Now let's click on this and you can see all over here, you have to add your API key, you have to add your index name. So you can see I created an index name semantic search demo. So you have to also create your index. Just go all over here and when you just click on getting started and it is going to ask you to create an index. So you can see at the down it says create an index all over here. So you can start doing up the setup. Now similarly you can see what is the cloud provider I'm using. It's AWS and the region is US East 1. So this is .env and it is basically storing all the environment variables that I'll be needing. Now the next file is requirement.e. So here are the different versions. So first of all, I need to have UVcorn and then FastAPI and Python.env and Pinecone client. So these all things I'll be needing. Now let us try to create a virtual environment and I'll be using terminal for the same. So just click on terminal all over here. Now, for creating the virtual environment, guys, you can go to the Python official documentation and you can see there will be a command which you can use to create a virtual environment. So there are a lot of things present all over here. So you can give the PTO virtual environment, okay, and you can also give all over here. Now, guys, let's try to paste this command python vnv, and let's say this is vnv folder. So it is going to create a folder which is a virtual environment, and it is a good practice to start with this. Let's wait for a couple of time till this is resolved. Okay, you can see all over here our virtual environment is created. Now, guys, after that you have to activate your virtual environment all over here, and this is done. Now let us try to explore the libraries that I have used all over here. So, guys, you can see all over here that in the requirement.txt I have created Pinecone client with version 2.2.2. So that I have added. Now this is used to connect Python with Pinecone. So python.env is used to read these secret values like API keys from the .env file, and after this you can also see FastAPI is also present, which is basically will be very helpful to create APIs, and UVCon is server, okay, that is running on the basically which we have installed all over here. Now you'd be wondering, why are we keeping all these values inside .env folders? So basically this is a security purpose such that we should not hard code these things, otherwise there is a chance of security issue all over there. Now let us create a class called as Pinecone operations. Now this class is important for operations such as creating an index, connecting to an index, inserting vectors, checking index stats, and searching similar vectors. So you can see all over here, first I have imported from .env, okay, and you can see all over here first is .env, then from Pinecone, serverless spec and Pinecone is there. Now all over here this class is Pinecone operations. So first loading all the environment variables from the .env file. Then I'm trying to access the API key, index name, what is a cloud, and what is a region. Okay. Now, if API key is not present, then I'm raising an error. Please add a valid API key. Also, after that, the most important thing, to connect to the Pinecone, we need to create a Pinecone client. Okay. So it is trying to access this variable API key, and it is creating a Pinecone client PC. And index object will only be created after connecting to the Pinecone. So self.index equals to none. Now let us create a method, create index, and I have given the dimension as a parameter, and let's say this is equals to 8. Then matrix is cosine. Now this is relatable to the vectors. So in a mathematical sense, we need these parameters to understand what is there. So dimension means that every vector must contain 8 numbers, and Pinecone will compare these values based on the cosine. So this is vectors if you would have studied in class 12th. So it is similar to kind of that when you have two vectors. So you use a cosine formula to actually compare the similarities. Now, if the self.index name is not present in the existing indexes, then you create an index, give the name, dimension, metric, and proper the serverless configuration like the cloud and the region. Now, this is very much important because all the operations that we have discussed will be happening all over here in this class. And we have to wait for the index to become ready. So while not self describe index, if the status is ready, then the time sleep is up to 1 second. Now we are returning the message and the index name when it is created. Also, if let's say if the index already exists, so we are giving the message that index already exists and trying to show the given index name. Now let us try to connect the application to the Pinecone index. So I have connected it using dictionary, which is taking one parameter string, and other it could take any parameter. Now here we are creating the index, and once it's connected to the Pinecone, I'm returning the message and the given index name. Now you can see we are trying to insert or update the vectors in the Pinecone. So we are using the upsert method for the same. Okay, so let's say sample input, let's say ID course1 values, these are the vector values, and let's say metadata title is for Python for data science, and let's say category I'm giving for data science. Now, if you talk about the response, so you can see I'm adding the vectors and namespace all over here. And after that, I'm fetching this and statistics about the Pinecone index all over here. And basically, when you're trying to access the index, so you get this message return as the index is fetched all over here. Similarly, for searching up the query, you can see sample query vector has been created. And if you look into the given responses taken up into the response variable, and first of all, we are connecting to the index. That's very much important. So top K results are returned, and you can see it includes the values, includes the metadata and the namespace. And finally, we'll return something like the search response completed successfully. Now let's look at to our main file where we'll be creating the API routes, and I'm using the FastAPI all over here. And you can see also I'm using the Pydantic model, which is very useful in this scenario. So first, let's create a FastAPI, and let's create an app first using FastAPI constructor. So we are giving title, description, and the given version number, and then I'm creating the object of the Pinecone ops that we created for all the given operation. Let's say this is the vector data. It is inheriting the base model, which is coming from the Pydantic model, and let's say ID, values, and the metadata. Then I'm trying to upsert the given request all over here, and the payload contains the vector data. Basically, it's in the list. Then let's say there is another class called search request, and it is also been inherited from the Pydantic model, where I'm basically storing the vectors and returning the top tills similar result or top K similar results. Now here are the decorators that have been created. So basically this is a get request for the health check, and this is an async function. So if you are not familiar about asynchronous, then please try to read about it, and it's present on the official documentation. Basically, asynchronous processes are somewhere where, let's say, for example, I'm giving a request to a weather API to fetch the data or the weather of, let's say, San Francisco. So the result might take a little bit of time. So the methods wait for the response to retrieve the result. Okay. Now, in a nutshell, you can consider asynchronous process as something where the waiting time is involved, and we calculate or store the response into variable, and async and await are the given thing that we use, mostly present in JavaScript. So guys, if you have studied async and await in JavaScript, it is very similar to that. So you can see it returns message okay, application running. Then this is a post request where you are basically trying to create an index, and this is the given API route, API v1 index, and using the Pinecone ops, I'm able to create an index. Then for connecting the index, this is something like this, and I have used Pinecone ops.connect. Then similarly get request, and this gets the index stats. Similarly, if you want to post the vectors, or let's say if you want to upsert the vectors, then this is the required async method. So where I'm basically appending the ID, values, and the metadata, and it is stored in the vectors via a list which I have created all over here. And finally, I'm returning the Pinecone ops.upsert method where the data are vectors. Then there is a post request on API v1 search vector, and this is an async request where basically we are trying to search the query, and it is returning the top K result all over here. So this is somewhat more about the main.py file. This is a very basic operation, guys, to connect to the Pinecone and try to return the result, basically semantically similar result. Now let's try to install the requirement.txt file. So guys, for installing the given the libraries that we have using all over here, so we have to type pip install, and given the name is requirement.txt, so the same name. Click on enter, and it is going to start installing all the given thing all over here. Let us wait for a couple of time till this process happens. Now guys, as you can see all over here, I have downloaded all the dependencies, and some of the errors which were showing because the dependencies were not present have also been resolved. So now it's time for us to run the program. So basically I have Python 3, so type Python 3, and let's say the file name is main.py. Let's try to run this. So guys, as you can see all over here, I have added command uvicon main app reload, and this is going to start our server. And you can see our server is running on 127.0.0.1 localhost. Let's choose Chrome as a browser. Now for checking up the API, we are going to use Requibin. So this is an online API testing tool. So you can see all over here, I've added metadata, title, category, courses, and all those things, and just click on send. So this basically adds the required thing in our Pinecone. So guys, this was a bit about Pinecone tutorial. I hope so you would have enjoyed our today's video. Thank you guys for watching this video.